Hey everyone, today we're going to discuss about the word problems on the discrete probability distribution. So the discrete probability distribution, let us recall that it lists down all the possible probabilities of a given value of a random variable. Now we can also use the mean and the standard deviation to interpret the discrete probability distribution. Let us remember that the mean, or the expected value of a probability distribution, tells the value of a random variable that is expected to be obtained if the experiment is done repeatedly, while the standard deviation or of a probability distribution indicates how far, on the average, an observed value of a random variable x is from the mean. We can also observe that the smaller the standard deviation, the more likely that an observed value of the random variable will be close to its mean. And the reverse is also true. The higher the standard deviation, the more likely that the observed value of the random variable will be far from the mean. So we can use those values in order for us to interpret real-life situations. So let's have a problem here. The probabilities of the number of available PCs in a computer shop on a busy afternoon are presented below. So there's no available PC, the probability is 0.465. If there's one available PC, the probability is 0.212. If there's two available PCs, the probability is 0.27. And if there are three available PCs, it's 0.053. Now, first question, what is the probability that there's at least one available PC? What's the mean of the probability distribution? And what's the standard deviation of the probability distribution? So let's start by answering letter A. In order for us to determine the probability that there's at least one available PC, we can add this probability here. There's one available PC, then there's two, and there's three, since it tells us at least one. So it can be two, it can be three. So we just add 0.212 plus 0.212 plus 0.27 plus 0.053. So we can add them up to determine the probability of there's at least one available PC. So that's 0.212 plus 0.27 plus 0.053. So the probability is 0.535. So this means that the probability that there is at least one available PC is 0.535. Now let's determine what is the mean of the probability distribution. So let's construct the distribution table here. So let's have three columns. This one is for x. This is for p of x, and this last one here is x times p of x. Then the values, let's input it here. So 0, 1, 2, 3, and the probability is 0.465, 0.212, 0.27, and 0.053. Then let's multiply these two here. So that would be 0 times 465, that would be 0. For the second one, 1 times 0.212, that is 0.212. For number 2, 2 times 0.27, 2 times 0.27, that is 0.54. And for number 3, 3 times 0.053, 3 times 0.053, that is 0.159. So let's add them all up. That would be 0 plus 0.212 plus 0.54 plus 0.159. The sum is 0.911. So this means that the mean of the probability distribution is 0.911. So it's more likely that when we choose a random variable x, it would be somewhere around 0 and 1. So what is the standard deviation of the probability distribution? Let's remember that this is our mean, okay? So this is mean is equal to 0.911, represented by the Greek letter mu. So let's have the standard deviation. Let's insert 4 rows here. So let's have again the x and the p of x right there. Then let's have on this column, so let's put it in center. So this would be x squared, and the last one is x squared times p of x. So let's get the square of the scores. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. And x squared times p of x would be 0 times 0.465 is 0, 1 times 0.212 is 0.212, 4 times 0.27, that would be 4 times 0.27, 1.08, and 0.053 times 9, 0.477. So let's add them all up. So that would be 0 plus 0.212 plus 1.08 plus 0.477. That would be 1.769. So that would be the value of x squared times p of x. Remember, that's not yet our standard deviation. Remember that the standard deviation is actually the square root of x squared times p of x minus mu squared. So that is actually our standard deviation. We've only obtained this part only. So let's have sigma is equal to square root of, this is 1.769 minus let's have the mean here. So that's 0.911 squared. So this is sigma, let's compute 1.769 minus 0.9, let's compute for the square first. 0.911 squared, so 0.911 squared, so that's 0.829921. Let's not round it off yet. 1.769 minus 0.829921. 0.829921. That's right, 0.829921. There. So let's compute 1.769 minus 0.829921. So that's 0.939079. Get the square root. That would be 0.96906 something something. So that would be 0.97, approximately 0.97. 0.97. So the mean is 0.911 and the standard deviation is 0.97. So if we select a random variable, since this is quite higher than compared with our last video, so we can expect that the value of the random variable will be not as close to the mean. So this is how we solve for word problems involving discrete probability distribution. I hope you guys learned a lot today. Thank you guys for watching, and see you guys on the next video.